All right, in 3.3, we are going to talk about dividing polynomials. So in part one, we're going to look at long division. Now, we say a polynomial, and we can call it d of x, is a divisor of a polynomial if there is a polynomial q of x, okay, we'll call q the quotient, such that f of x equals d of x times q of x. Now, we'll look at examples of what this means here in just a second. But we're always going to write our answers as whatever we get as the quotient plus the remainder divided by the divisor. So let's jump in and see what that actually means. So if I want to divide x squared plus 7x plus 12 by x plus 3, I'm going to set up a long division problem like this. I'm going to put the divisor on the outside and the dividend on the inside. So the process for dividing polynomials, I want to look at the first term in my divisor and see what I need to multiply that by to get the first term in the dividend. So x times what equals x squared? Well, x times x would be x squared. So that goes up here. Another way of thinking about that would just be to say, well, if I take this first term and divide it by this first term, what do I get? I get x, right? So then once I figure this term out, I take this and multiply it by every term in the divisor. So x times x gets me x squared, and x times 3 would be 3x. And I just write that or those terms underneath of my divisor, and I subtract them. Now, every time, these first terms should cancel out. X squared minus x squared cancels out. And then 7x minus 3x would get me 4x. So then I want to repeat the process. I just say, well, what do I need to multiply x by to get 4x? I did forget, we want to bring down our next term, right? So now we say, well, what do I need to multiply x by to get 4x? Well, x times 4 would be 4x. So I put 4 up here in my quotient, and then I multiply 4 times every term in the divisor. So 4 times x is 4x. 4 times 3 is 12, and I subtract. So 4x minus 4x is 0, and 12 minus 12 is 0. I have nothing left to bring down, so my remainder is just 0. My answer here then would just be x plus 4 with no remainder. Okay? Now, another way of writing this would be to say this means that x squared plus 7x plus 12 is equal to x plus 3 times x plus 4, the divisor times the quotient. All right? So let's try a few more examples here. In the next one, we're going to set this up the same way. We'll have x minus 3 divided into 2x squared plus x plus 6. So the first step, look at the first term in the divisor and see what we need to multiply that by to get the first term in the dividend. So x times 2x would get me 2x squared, and then take this value and multiply it by every term over here. So 2x times x is 2x squared. 2x times negative 3 would be negative 6x, and we subtract. So 2x squared minus 2x squared cancels out. X minus negative 6x would really be x plus 6x. So that would get me 7x. And then I bring my next term straight down and repeat the process. So x times what would get me 7x? Well, x times 7. And then 7 times would get me 7x minus 21. And I subtract. So 7x minus 7x cancels. 6 minus negative 21 would be 6 plus 21. So that gets me 27. And now, since I don't have anything to bring down, this is my remainder. So the way that we write a remainder, we just say plus 27 over the dividend, so over x minus 3. So we can write that as our answer over here. We can say this equals 2x plus 7 plus 27 over x minus 3. Okay? In the next example, we just have 4 terms in my numerator. It's going to be the same process. So let's go through this one here. 2x cubed plus 7x squared plus 2x plus 9. So I just want to see what I need to multiply this first term by to get this first term. Well, 2x times x squared would get me 2x cubed. And again, another way of thinking about that is just to take this first term and divide by this first term. So 2x cubed divided by 2x would get me x squared. So then multiply x squared by everything over here. X squared times 2x would be 2x cubed. X squared times 3 would be 3x squared. And subtract. So these cancel. 7x squared minus 3x squared would be 4x squared. Then bring the next term straight down. So now I would need to multiply 2x by 2x to get 4x squared. So 2x goes up here, and 2x times 2x is 4x squared. 2x times 3 would be 6x, and subtract. So these cancel. 2x minus 6x would be negative 4x, and bring the next term down. 2x times negative 2 would get me negative 4x, and multiply negative 2 times everything over here. So negative 2 times 2x is negative 4x. Negative 2 times 3 would be negative 6, and subtract. So these cancel. 9 minus negative 6 would be 9 plus 6, so that would be 15. I have nothing left to bring down, which means 15 is my remainder. So we always write a remainder like this. Okay, so I can write my answer here as x squared plus 2x minus 2 plus 15 over 2x plus 3. Okay. 2 more examples, and in each of these, something a little bit different is going to happen. So, but the process is going to remain exactly the same. So my divisor this time is a trinomial. I've got 3 terms in there. And my dividend is a 4th degree. Now, if we look at this, I do not have a 3rd degree term in here. If we are ever missing a term, when we look at the powers in descending order, we have to put a placeholder in. That's true of the dividend or the divisor. So the way that I'm going to write this, when I put this under my division bar here, I'm going to put in a 0 x cubed. I need a placeholder whenever I'm missing a term. Okay? So then minus 13x squared plus x plus 35. All right, so whenever we're missing a power, when we're looking at the powers in descending order, we need a 0 placeholder in either the divisor or the dividend. But now the process that we just went through is going to remain the same. So I want to look at my first term here and see what I need to multiply by to get the first term in here. Well, x squared times x squared would get me x to the 4th. Then take x squared and multiply it by every term in the divisor. So x squared times x squared would be x to the 4th. X squared times negative x would be negative x cubed. And x squared times negative 6 would be negative 6x squared. And subtract. So these cancel. 0 minus negative 1 would be 0 plus 1, so that'll be 1x cubed. And negative 13 minus negative 6 would be negative 13 plus 6, so minus 7x squared, and bring the next term straight down, so plus x. Now, x squared times x will get me x cubed, and then multiply x times everything here. So x squared times x will get me x cubed. Negative x times x will get me negative x squared, and negative 6 times x will be negative 6x, and we are subtracting. So negative 7x squared minus negative x would be, or minus negative x squared would be plus x squared. So that'll get me negative 6x squared, and x minus negative 6x would be x plus 6x, so plus 7x, and bring the next term straight down. X squared times negative 6 would get me negative 6x squared. So multiply negative 6 times each of these. We'll get negative 6x squared plus 6x plus 36. And I am subtracting. So 7x minus 6x would just get me 1x, and 35 minus 36 would get me negative 1. I don't have anything left to bring down, so this is my remainder, x minus 1. So we'll write that as plus x minus 1 over x squared minus x minus 6. Okay? My remainder could be as large as always as being 1 power less than my divisor. So here my divisor was second degree. That means I could end up with a remainder of a first degree. If my divisor was third degree, I could have a remainder that would be a second degree polynomial. Okay? So my answer here is just x squared plus x minus 6 plus x minus 1 over x squared minus x minus 6. Right? One last example. Right? And in this one, there are a couple of things that we have to make sure that we're doing correctly. So when I write out my divisor and my dividend, I need to make sure that they are in order of descending power. So my denominator here, my divisor, I would need to rewrite this as x squared minus x plus 1, so that it's in order of descending power. And then here, okay, I would have x to the 5th. I do not have an x to the 4th term, so I would need a 0x to the 4th. I've got an x cubed, so plus 4x cubed. I have an x squared, so plus 2x squared. I do not have an x to the 1st term, so again, I need another placeholder, so plus 0x, and then plus 9. Okay, so two things we need to make sure of in a problem like this: that we write both our divisor and our dividend in order of descending power, and if I'm missing any powers, I need to put in a 0 placeholder. All right, so then once we get that set up, the process is exactly the same. What we need to multiply x squared by to get x to the 5th, well, that would be x to the 3rd power. Then take x cubed and multiply it by all of this. So x cubed times x squared would be x to the 5th. X cubed times negative x would be negative x to the 4th. X cubed times 1 would be 1x cubed. And we subtract. So 0 minus negative 1 would be positive 1. 4 minus 1 would be 3x cubed. And bring the next term down. And repeat the process. So x squared times x squared would get me x to the 4th. Then multiply x squared times everything here. That would get me negative x cubed plus 1x squared, and subtract. So these cancel. 3x cubed minus negative x cubed would be 4x cubed. 2x squared minus x squared would be 1x squared. And next I'm bringing down a 0x. Then x squared times 4x would get me 4x cubed. So 4x times all of this would be 4x cubed minus 4x squared plus 4x. And subtract. So x squared minus negative 4x squared would be 5x squared. 0 minus 4x would be minus 4x. And then I'm bringing down the 9. So x squared times 5 would get me 5x squared. So plus 5. Then 5 times my divisor would be 5x squared minus 5x plus 5, and subtract. So these cancel. Negative 4 plus 5, right, because that would be a double negative, would just be 1x, and 9 minus 5 would be 4. So x plus 4 is my remainder because I have nothing left to bring down. So this will be plus x plus 4 over x squared minus x plus 1. And I can write this whole thing over here as my answer. I can say this would be x cubed plus x squared plus 4x plus 5 plus my remainder over my divisor. Okay, so that is it for this video. The final question is going to pop up asking you what questions you have.